So I want to show you what happens when you hook up some electricity. So right here we have pure water, there's nothing in it, and you'll notice that our light bulb is not lighting up at all. And that's because there's no positive or negative charges. Well, there's a partial positive and partial negative, but I mean, it is just the tiniest percentage of water that'll break apart into ions, just the tiniest of tiny percentages. And so you're noticing this isn't setting up the light bulb. Now, when we put salt in, I'm going to put a whole lot of salt as NaCl. We've got those positive and negative charges. And so all we need to make a light bulb light up or to get electrocuted is to have a reason for the electrons that are coming from either the battery or they're coming from, lightning or whatever they're coming from, your electric socket. The electrons just need to have a reason to flow. And so when you're putting that positive, negative, and the salt in, and it falls apart into those different charges, now all of a sudden your electrons can be repelled from the positive sodiums and attracted to the negative chlorines. In contrast, if I give it sugar and I set up the conductivity, remember the sugar isn't dissolving because it's attracted to the poles of the water per se. It's doing hydrogen bonding, yeah, but it's not trying to split apart. And so because of that, we don't have anything going on with our light bulb right there. So you can see that there's a difference. And I just want to point out that the more concentrated it is, you can see our light bulb is growing stronger and stronger. And if I evaporate the water, see, it gets even stronger. So the more concentrated it is. So the strong electrolyte is something that will break apart in water. A non-electrolyte is something that's got like lots of hydrogens and oxygens, and it won't split apart in water. And then you could also have a weak electrolyte. And a weak electrolyte is something that only kind of splits apart in water some of the time. And I have a similar simulation, but this one shows it better. So in this case, I have something that is slightly soluble. So you can see some of them are falling apart and some of them aren't. So you can kind of see like some of them are sitting on the bottom. And if you watch it carefully, like it'll rejoin and unjoin. And so in this case, it's just slightly soluble, and some of it just won't dissolve in. That'll just look like a big pile of, if this were a white salt, it'd look like a big pile of white at the bottom. So when you set a light bulb up with this, it very, very faintly can glow because some of the ions are dissolving, but not all of them, because this is not very concentrated.